If you have a book and would like to join me, I'm on page 607, and section 9.3 is on the complex plane. This is on the complex plane. And we're going to be looking at several things for complex numbers, okay? Polar coordinates, complex numbers. One of the things that it mentions is de Moivre's theorem. And that's just a special formula in this section. That doesn't mean the complex plane is all about de Moivre's theorem. De Moivre's theorem is one of the concepts in this whole section, okay? All right, so let's start with problem number 19. And they give me 4 minus 4i. And being trig students, y'all should have had college algebra at some point, and y'all should be familiar with complex numbers. A plus bi, standard form of a complex number. And here they want us to plot each complex number in the complex plane. Right, we want to plot the complex number in the complex plane. So in the complex plane, it's no longer x-axis and y-axis. Now it's real axis and imaginary axis. But it works just like an x and a y, okay? So in this complex number, which number is the real part? The positive 4 is the real part. So we're going to go over to positive 4. And then what is the negative 4? That's the imaginary part. And since it's negative, we're going to go down. And do you see it works pretty much just like an x and a y? The real part is the x, the imaginary part is the y, if you want to think of it that way. And that's how you put the dot in the right spot. Any questions? Okay, the instructions also say write the number in polar form, and we're going to have to know how to convert from standard form to polar form. And so that means we're going to need a formula. Okay? So the radius is going to be the square root of a squared plus b squared. And theta is going to be the inverse tangent of b over a. So we're going to need these two formulas. And again, if you remember from your college algebra, the a and the b, that comes from your standard form. So the 4 is the a, and the negative 4 is the b. So far, so good? Okay, now let's calculate the radius. That's going to be the square root of 4 squared plus negative 4 squared. And my guess is 4 square root of 2 if you write it in simplified radical form. Any of y'all have the calculator that you can put that in and it gives the simplified radical? I'm sorry, does anybody need me to show how I got there? Put my glasses on so I can see. No? Okay, I will. So, what is 4 squared? But what is negative 4 squared? And 16 plus 16 is? But I can rewrite 32 as 16 times 2, and the square root of 16 is 4. So the 16 is going to get to come out. That's where the 4 out front comes from, and the 2 left over underneath. And now we need to calculate theta. Okay, that's going to be the inverse tangent of negative 4 over 4. But negative 4 over 4 reduces to negative 1. And then what is the inverse tangent of negative 1? And I guess I'll accept that in either radians or degrees, either one. Negative pi over 4. And if you remember from last time, I don't really like negative angles. I'd rather it be positive. So can y'all give me the positive equivalent to negative pi over 4? 7 pi over 4. Does everybody see how I get that? Add 360. Yeah. Right? Because a negative angle goes clockwise, and negative pi over 4 is going to be in the 4th quadrant. And if I want to start in the 4th quadrant and return to the 4th quadrant, how far around do I go? A full circle. So if you have a negative angle, you can always add 360, which is 2 pi, and get the positive equivalent. You can. Now, some of y'all may have been thinking back when I said, if x is negative, add 180 to theta. That's a whole different thing, okay? Adding 180 to theta, a whole different thing. Wow, okay, so I'm about to give you 2 more formulas. Okay, go ahead. Oh, good. I'm about to give that, okay? So, since we're talking about complex numbers, okay, they normally use the letter Z to indicate that we have a complex number. So we can say Z equals A plus BI, and we call that standard form. Or we can say Z equals R cosine theta plus I sine theta. And this is polar form. So you ask me, how do you write that as an ordered pair? And the answer is you don't. If it's a complex number, it has to be in this formula or in this format to be in polar form. Okay? So, we started with a complex number in standard form, correct? We plotted it, and then it said convert this into polar form. But do you see, in order to write polar form, I have to know r and theta. And that's why we did this calculation here. All right, so now we can say that the answer is 4 square root of 2, parenthesis, cosine of 7 pi over 4 plus I sine of 7 pi over 4. And I don't know, I felt the need to set that up off with color. because those are the formulas we're using there.
So we'll never plot the imaginary?
We did plot the imaginary right here?
Or we won't plot it in polar form?
No. It's easier to plot in standard form because it works like a rectangular coordinate. But you might need to convert from rectangular to polar. Standard form or rectangular form to polar form. Now, how many of y'all have the nice calculator, the Casio that I recommended? Okay, so what I'd like you to do, really to practice your button pushes, but also to verify that I haven't lied to you, would you please input all of this stuff in the box? The 4 square root of 2, open parenthesis, cosine 7 pi over 4. Oh, I'm sorry, before you actually start typing that, you actually need to be in complex mode. So you need to hit mode 2 and then start typing. You're going to have to be in complex mode so that you can type the I in there. So that's mode 2. And then how do you get the I? It's the ENG button. If you just hit the ENG, that gives you an I.
Wait,
Did that again? Mode 2. There you go. And now start typing. That's cool though, you're doing. What do you got? Mode? Do you have complex mode on your calculator? Mode. You hit shift mode, hit just mode. No, hit clear. No, you can't do an I on your calculator. Dang it. I knew there's a reason I didn't like that 300. How you doing? 4 square root 2. Yeah, something is messed up. I'm going to reset it, okay? So let's do shift 3. Yes. Now hit mode 2 and then start your 4 square root. Okay, now that looks more like oh, there we go. All right, so I'm trying to get you guys to input this in your calculator just the way it looks in the box and hit equals and see if it gives this back. Okay, so if it does, then that verifies that this is written correctly because if you input it, it gives standard form, rectangular form. There needs to be an open parenthesis right there.
Oh, okay. Well, I still got the 4 down here.
Why is your fraction not making it an actual fraction?
Yeah, I don't know. That's what, yeah. I got a decimal.
Huh? Where's yours?
Every time I press fraction, it gives that. Yeah, same.
Okay, set your calculator down here. You set yours down. Shift 9. 3 equals 3. Now, mode 2. Now start typing.
4, 3, 2.
Yeah, AC key. And then mode 2. Now start typing. You put it under the, there you go. Parenthesis. Fraction. Now it's doing what it's supposed to do. How's yours? Oh, good. Anybody else need calculator counseling?
I know that my calculator is a different Casio, but it does most of the others.
Yeah, but it won't do the I.
Sure.
I'm positive, because I just looked at another one just like yours.
On that fence.
Yeah, it won't do an I on it because it doesn't have a complex mode. Yeah.
Oh, yeah, I forgot that's the I got a 4.
Okay, so hit shift 9, 3 equals mode 2. Let's start typing. Now it's fixed it. Okay?
Oh, I see.
I'm sorry, this is
I'm in the
downside of
I
that.
have like
Well, I wanted to be
seven.
degrees already.
Radians. You have to be in radian mode.
Yeah.
Okay. Yeah, so get clear. And let's start typing forward square root. Move out from under. Both sides. Fraction button. Now, you see this with the eye on it? Hit that 3 times. That's how you got it. Got it? Okay, good. Uh-oh. See, your square root is extending too far. So you need to do 4 square root, 2, and now move out from under it, put an open parenthesis, and then cosine. There you go. Keep going with this. How are we doing? Oh, it's another. 3 people in here have the freaking Casio 300. Which yours can't do an ion. Yeah, it's E right above E and T. So, unfortunately, that's not going to do complex numbers for us. Oh, okay. Radian mode, yeah, but you also have to be in complex mode, which is mode 2. And then we're going to go 4 square root 2. Cosine. Yeah, it has to have both complex and radian. And then cosine. Yeah. Now keep going. And then when you get to the E and G, it'll. How are we doing? There you go. What more are you going to get? Plus, and then this E and G button. There's your eye. How are we doing? God, good, good. I'm sorry, I'm just trying to give good instruction here and make sure everybody's coming along. How's yours? What about on this guy? Actually put 7 and then do 9. And divided by. We won't let you stack it right. Plus. And then I is second period. We'll do an I. Oh, good. Mode. And, oh, it's not in red, it's in degree mode. Easy fix. Cool. So you can do it both ways. All right, anybody else have questions about this example that we just did? Anybody questions about number 19? Because we're about to move on and do another one. Number 23. Negative 2 plus 3i. And do y'all see that that is in rectangular form, a plus bi form? And so the first thing we want to do is plot. We want to plot that in the complex plane. So which direction does the negative 2 go? Left. And the positive 3? Up. That's tough stuff, isn't it? Well, it works just like an x and a y. Yeah, except remember this is real and imaginary. And then we want to convert that into polar form. So we're going to have to find r, which is the square root of negative 2 squared plus 3 squared. 4 plus 9. Yuck. And that's not going to square root nicely. And so we're going to have to leave that square root of 13. So far, so good? Okay, next. Theta. That's going to be the inverse tangent of B over A. So what is the inverse tangent of 3 over negative 2? And are you going to be in radian mode? As soon as somebody gets a number, I'd like to have it. Negative 0.98. First of all, it's negative, right? Which means to spin clockwise. And 0.98 is actually not even to here. It's like somewhere in this quadrant. Okay, we got a problem here, people. Do y'all see my dot is in quadrant 2? But the angle is in quadrant 4. That's 180 degrees out of phase. So do y'all remember the last section I taught? I said if x is negative, you have to add 180 to theta. Do y'all remember that?
Yeah.
Well, I'm sorry, but it applies here too. Now you're going to say if A is negative, you have to add 180 to theta. If A is negative, add 180 to theta. So what is 3.14 minus 0.98? 3.14 minus 0.98 is 16 radian, and that's radians. Okay, so now that we know r and theta, now can I write the complex number in polar form? All right, so here we go. We're going to say z equals square root of 13 cosine of 2.16 plus I sine of 2.16. And since y'all are all now pros at putting that in your calculator, I'd like you to plug all of that in your calculator and see if we get something close to what we started with. I don't think it's going to be exactly right because we rounded the angle. But it'd be nice if you input that and see if we get something close.
Yeah.
Okay, negative what?
2.003.
Blah, 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 right?
Yeah, and then the next one was plus 2.9975. So it's close.
Yeah, so the negative 2 point blah, 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 rounded to negative 2, right? And the next number, the 2.99 rounds to 3, and that's my imaginary part. So yeah, I feel good about that. When I put this in the calculator, it gives me something really close. Close. It's close enough. No. No. Because I'm not going to be asking you to go from here to here with a approximate number like that. No. But I will be asking you in a second, we will be converting from polar back to rectangular. Okay? Do y'all understand what we're doing now? We're going from rectangular to polar. But if you had to go from polar to rectangular, I hope you're starting to see that that's just entered in the calculator. That's the freaking easy way to do it. What up?
Why did you put the 2.99 instead of the negative 0.200?
Oh, somebody told me that that was on the calculator. Is it on your calculator?
Mine is negative 2.0036.
And does it have more stuff?
It has a lot more.
Keep scrolling over.
Oh, okay.
And eventually does it come to plus 2.99? And if you keep scrolling over, does it have an I? Okay. So we just estimated instead of writing all that junk down. Okay, any questions so far? Anybody? All right, the next problem that we need to look at is number 25. 2 cosine 2 pi over 3 plus I sine 2 pi over 3. Now, tell me, is that a complex number in polar form? Okay, and we know that for two reasons, okay? First of all, did you see the I in there? That makes it complex. And if you have sine and cosine, that makes it polar. So this is a complex number in polar form. I need you now to convert back to rectangular form. Okay, yeah. The fact that we have trig functions, sine and cosine, makes it polar. The I makes it complex. And so we're going to convert this back to rectangular form. And I know some of you can't put the I in the calculator, right? And so I'm going to show you a workaround. How can we still use the calculator even if we can't put the I in there? We can distribute. Let's distribute the 2. That's going to be 2 cosine 2 pi over 3. And that can be calculated. Plus 2 sine 2 pi over 3. That's going to have the I, but everything without the I can be calculated. So you can calculate those two pieces separately. So let's see, what is 2 cosine 2 pi over 3? Negative 1. And what about 2 sine of 2 pi over 3? Is that square root of 3? Square root of 3? So how was that? Not bad? And even if you can't put an I on your calculator, you can still do this. You just have to do it in 2 separate calculations. Do y'all think you need to see another one of those, or was that easy enough? You don't need another one of those? No, okay, we'll do one more. Let's do number 26. And that's going to be 3 cosine 7 pi over 6 plus I sine 7 pi over 6. And let's convert that from polar to rectangular. And again, doing the distributive property, 3 cosine of 7 pi over 6 plus 3 sine of 7 pi over 6 I. And I'm wondering, does your calculator actually give that fraction?
Yes.
That's freaking nice. I don't know if you know that, but a TI-84, $120 calculator won't give that. But your little $15 Casio will. That's messed up. Yeah. And what about the second part, the complex, the imaginary part? There you go. Rectangular. That's polar to rectangular. Go ahead.
Am I getting something different because I'm putting the whole first part in? I got negative 1/2.
I think it's mainly because you forgot to put the parenthesis after the 3.
Oh, okay.
I'm sorry, you're doing it in 2 separate pieces? Yeah, so if you're doing it all at one time, you're going to need that parenthesis.
Wait, why is it minus 3 over 2?
What did you get? Oh, you didn't put the 7. Might have something to do with it. Did you do it?
Yeah.
Anybody else having calculator issues? Now, before I move to the next new thing, I'm going to ask you how you feel about a couple of things. How do you feel about converting from rectangular to polar? Starting with an A and a B and getting an R and a theta. What about going from polar to rectangular? So are you telling me that you feel pretty comfortable going both ways? Yeah, thanks for laughing. Yeah, okay, so now what we're going to do is we're going to look at how do we multiply complex numbers that are in polar form, and how do we raise complex numbers in polar form to powers. We're going to be looking at those two things. So, I've got a couple of formulas for you, okay? Let's say that we have our first complex number, R1 cosine theta 1 plus I sine theta 1. And Z2 is R2 cosine theta 2 plus I sine theta 2. And so we've got two complex numbers in polar form. They're going to have different radii, R1 and R2. Their radiuses are different. And they're going to have different angles, theta 1 and theta 2. And we want to look at how do I do Z1 times Z2. How does multiplication of complex numbers in polar form work? And so here's the formula. It says you take your radii, and what do you do with the radii? It rhymes with radii. Multiply. It multiply. And then we're going to have cosine of, and that's what you do with the angles. Now, does that formula look big and nasty? Okay, let me let you in on a little secret here, though. If you know how to multiply numbers together, and if you know how to add numbers together, you got this. Because that's all that's involved. You're going to have to know how to multiply and how to add. And that's it. So let's look at problem number 41 for our example.
What is that X figure down the line?
Where's there? Oh, this means multiply. Z1 times Z2. All right, so we've got, for number 41, Z equals 2 cosine pi over 8 plus I sine pi over 8, and W equals 2 cosine pi over 10 plus I sine pi over 10. And we want to find Z times W. We want to find the product of those complex numbers. So what does the formula say to do with the two radii? Multiply. 2 times 2? 4. Parentheses. Cosine. Uh-oh. What does the formula say to do with the angles? Add them. Oh, but what do I have to add fractions? No, calculator. Okay, fine, you're right. Common denominator or a calculator. Yeah. So let's do pi over 8 plus pi over 10 and see what we get. Pi over 8 plus pi over 10. I'm waiting. What is it? 9 pi over 40? Sorry? Anybody else verify that? Pi over 8 plus pi over 10 is 9 pi over 40. Plus, now I've got some good news for you. It's the same thing, right? So you only have to do it once. All right, so I would like to let you know that this is where you're going to stop. This is the final answer if it says write your answer in polar form. Because that answer is polar form. But what if it says write your answer in rectangular form? Well, then you're going to have to push buttons. So let's go ahead and write that in rectangular form also. So on your calculator, you're going to have to do 4 cosine 9 pi over 40, and I'd like that rounded to 2 decimal places. What is 4 cosine 9 pi over 40 to 2 decimal places? Megan? All right, and in a separate calculation, you're going to have to do 4 sine 9 pi over 40. And I'd like that number to 2 decimal places. 4 sine 9 pi over 40. 6.60. Positive or negative? Anybody else agree with 2.60? Rounded to 2 decimal places?
Oh, I think it's actually 0.649.
Yeah, okay, great. You can just put it like straight up in the calculator.
Straight up, yeah, in the calculator. Without what?
Separating.
Yeah.
I did that and I got 2.5 and we tried to.
Okay, and the reason is because your calculator allows you to put the I in there.
Okay.
But for the people that can't push the I button, you have to do it in 2 separate calculations. And what are you saying, Carlos?
I said I've got 0.649 as the second part.
And you did 4 sine 9 pi over 40? 4 sine 9 pi over 40. I better come look then. Well, you're doing it all at one time. So you're going to have to do, since you're doing it all at one time, you're going to have to put the open parentheses.
I don't take notes. I don't know. This is what happens when I take notes. It's like, no. Sign. Yeah.
Yeah, so since you're doing it all at one time, just sign in there, you're going to have to type it in for parentheses.
I never go back and look at my notes. So if I take them, it's not that I'm going to go back and study them. It's just enough like his notes on mine. I study his not.
All right, next formula. And I apologize for only doing one example, but I hope you got how it works. The one example of how product works. And did y'all see it's really not that tough? Yeah, you got to know how to multiply numbers and how to add numbers there. And a lot of it is calculator use friendly, right? So we're also going to have to know how to take a complex number and raise it to a power. And there's the formula for that. We're taking a complex number and raising it to a power. And the example we're going to look at is number 49. And that says square root of 3 cosine of pi over 18 plus I sine pi over 18 raised to the 6th. All of that raised to the 6th power. So can y'all see that this is definitely a complex number in polar form? All of that being raised to a power. So this is how we know that we're going to use the power formula, written down right here. And can you tell me in this problem, what is the value of n?
6.
Yeah, see, n is the power. So what does it say to do with the radius? Raise it to the 6th. But what does it say to do with the angle? Multiply by the 6. So here we go. We're going to take the radius, which is the square root of 3, and we're going to raise it to the 6th. And then we're going to do cosine of the angle multiplied by 6. And of course, you're going to need to simplify that. So does anybody know what square root of 3 raised to the 6th power is? What was that? 27. And does everybody know how we get that? Calculator. It's called the calculator. You put the square root of 3 in parentheses, raise it to the 6th, and the calculator spits out 27. Okay? Now, what about 6 times pi over 18? We can actually do that manually. 6 goes into 18 3 times. Yeah, that reduces to pi over 3. And how many times do I have to do that? Only once, because the other one's going to be the same. And let's put a box around that, because that's the right answer. And that's where we're going to stop if it says write the answer in polar form. You got to pay attention to the way the instructions are worded. It may say write the answer in polar form, and you're done. Or it could say write the answer in rectangular form, and that means you need to go one more step. I do, please. So what is 27 cosine pi over 3?
I got 27 over 2
Positive?
plus
Okay, plus.
27 square root of 3. I mean square root of 3 over 2I.
And let's see who agrees with you. Oh, you got it? Thought I heard somebody say nope. Maybe they said dope. That's dope.
Can you put the very original problem in the calculator as is with the parentheses?
I think so.
Yeah, that's what I did.
If you have the Casio, I think you can put it in.
And that'll give you the final answer. Okay. It's rectangular.
Right. So the problem is if they ask for it in polar form,
Doesn't know what you're doing.
the calculator's going to skip that. Yeah. So you see, I can make up a problem that even if you know how to use the calculator, you're not going to get what I want. Yeah. So I can do that. I didn't say I would. I said I could.
Couldn't you just go from polar, from standard to polar?
You could. I mean, you could say, hey, this is A and this is B, and you could get R and theta and go backwards. You could. Does anybody have any questions on that? Okay, so do y'all remember way back up at the beginning, I put that weird name, de Moivre's theorem? That's de Moivre. Yeah, that's de Moivre's theorem. If you go Google de Moivre's theorem, that's it. It's the power formula that I gave you there, okay? That's de Moivre's theorem. And believe it or not, I have covered an example of everything you're going to see on your My Math Lab assignment.